In this video, we would like to give an introduction to 3D graphics. In the course of the past videos, we have seen and touched upon the 3D dialog of objects again and again. In this video, we would like to give a full introduction. For this, we insert a station in our frame. First of all, we can open the dialog of the station. In this dialog, we have the possibility to adjust the simulation settings. There are several ways to open the 3D dialog. In the lower left corner, we can click on 3D and would get to the 3D dialog. Another possibility would be to right-click on the station and select Edit 3D Properties. The third possibility would be to use the shortcut. However, there is another shortcut, and that would be to select the station and then press the spacebar. In the Edit 3D Properties dialog, we can adjust visualization settings. The first tab in this dialog is the Transformation tab. In the first group box, we can change the position of the station. If we know the exact coordinates, we can enter them into the corresponding fields. Otherwise, we can also use the mouse wheel. If we turn the mouse wheel, then the object moves by 0.1 meter steps. If we press the Shift key while turning the mouse wheel, the object moves by 1 meter steps. If we press the Control key while turning the mouse wheel, the object will move by 0.01 meter steps. From the Inheritance checkbox, we can see if the position is inherited or not. If you are not familiar with inheritance, we recommend you to watch the corresponding video. However, you can see that the Inheritance checkbox is grayed out. The reason for this is that the class of the station is located in the Material Flow folder, and therefore it would not make sense to inherit the position. To illustrate this, let's open the Material Flow folder in a 3D window. First, we see that the edges of the frame are yellow. This is an indication that we are in the 3D window of a folder. All objects that are not a frame would have green edges. Secondly, we can see that all classes of the Material Flow folder are arranged in this frame. The station is located in the lower right area. However, the coordinates of this class do not represent a meaningful position in a frame. For this reason, the inheritance of positions of a class that is arranged in a folder was switched off as a safety precaution. Keep in mind that if you move the station while the Edit 3D Properties window is open, that as soon as you press Apply or OK, the station will be moved to its previous coordinates. The reason is that by moving the station, the position of the coordinates in the Edit 3D Properties won't change. And when you then click OK or Apply, the coordinates in the Edit 3D Properties dialog will be applied. In the next group box, we can set the rotation of the object. In the first field, we can enter the rotation angle. Here we can again use our mouse wheel and the Shift or Control keys. As we can see, the object will then be rotated around the Z-axis. To change this, we can click on the button to the right of the desired axis. So if we want to rotate the object around the Y-axis, we can click on the button. If we now increase the angle, we will see that the station is rotated around the Y-axis. If we click the button to the right of the X-axis, the station will be rotated around the X-axis. In the Mirror Group box, we can select the plane on which the object will be mirrored, if that is desired. In the last group box, we can adjust the scaling of the object. By default, Uniform is selected here. This means that all axes are scaled with the same factor. If you want to scale individual axes, you can deselect Uniform and enter the scaling factor for the specific axes. Here you can again use the mouse wheel and the Shift and Control keys. Now we insert a conveyor and open the Edit 3D Properties dialog. Here we can see the Appearance tab, which was not available in the dialog of the station. The reason for this is that for objects whose attributes have an effect on the graphical representation, the Edit 3D Properties dialog contains the tab Appearance. In the Appearance tab, we can open the Segments table. The Segments table has already been explained in the video about the conveyor, so we won't go into it in more detail. Next to the Segments table, we can edit the height and the width of the conveyor. Then we can see the Configuration group box. In the first drop-down, we can select the type of the conveyor. Here we can switch to a roller conveyor, for example. However, it should be kept in mind that some representations of the conveyor can be more rake-intensive than others. To illustrate this, we will insert another conveyor next to the one whose type we have changed. Then we switch to the View ribbon and click on Wireframes. Here we can now see the polygons or triangles through which the two objects are built. As you can clearly see, the roller conveyor is much more complex than the native conveyor. Then we switch off the wireframes again. In the next group box, we can change the appearance of the conveyor's legs. Additionally, we can change the type of the legs and the material of the legs. In the Material dialog, we can adjust the diffuse, ambient, specular and emissive color. For most cases, it is enough to just set diffuse color. Ambient color is the color emitted from the environment to the object. Specular color is the color that is reflected from the object to the environment. Emissive color is the color that is emitted from the object. You can use the emissive color to visualize a piece of glowing steel. Additionally, we can adjust the transparency and shininess. We can then also copy the current material settings and then use it for the rollers or the support frame. Furthermore, we can also adjust the diameter of the legs. We can also change the multiplicity of the legs. For example, we can set the legs to be on one side only, or select equidistant and then set the distance between the legs. In the next group box, we can adjust the appearance of the rollers. Here we can change the material settings and the diameter. In the last group box, we can adjust the appearance of the support frame. To showcase the MU Animation tab, we switch to the Edit 3D Properties of the station. Here we can now show the animation path. The animation paths are used to animate the MU on the material flow object. Now, if we were to place a part on the station, it would be inserted at the default animations path. We can then also adjust the side at which the part is attached. When we select left and apply the changes, we will see that the part is attached accordingly. The alignment is always made from the viewpoint of the part in the conveying direction. In addition, we can select the cone and change the orientation of the part using the key combination Ctrl-Shift and the arrow keys. If we do not like the position of the default animation, we can select the cone and use the arrow keys to set the desired position. Additionally, we can double-click the cone. In the dialog, we could now enter the exact coordinates of the desired position. As we have seen many times, parts coming into the station are only placed on the default animation path and passed on to the successor after the processing time. If you want to show in the animation how the part passes through the whole station, this can be easily achieved by extending the animation path. To achieve this, we place the default animation path on the left side of the station and press Extend afterwards. Now we place the second anchor point on the right side of the station. We then insert a source and a drain. Now when we start the simulation, we will see that it is simulated how the part moves through the station. The tab self-animation and poses will be explained in the next video. We will now explain the Graphics tab. We therefore duplicate the station class. Then we place an instance of the class into the frame and open the Graphics tab of the class. In the Graphics tab, we add 2 new graphic groups and close the dialog. Then we open the station class in a new 3D model and align it next to the model frame. We will now place a rack where, for example, material can be stored that is used to fix a failure on the station. When inserting the rack, we must select the graphic group to which it will be assigned. We select the first graphic group. As we can see in our model frame, the graphics of the station have instantly adjusted. Then we again place a rack and assigned it to the second graphic. Let's assume that we have assigned the rack to the wrong graphic group. In such cases, the rack can simply be removed using the key combination Ctrl and X and inserted again using Ctrl and V. When inserting, we can now change the graphic group. Now let's assume that in the inserted instance of the class, the first pillar should not be displayed. To achieve this, we can now switch off the visibility in the Graphics tab of the instance. When we apply the changes, the pillar will no longer be shown. Next to the visibility, we can also select Locked. This basically sets if selecting and transforming the graphic group in any 3D window will be prevented or not. Keep in mind that changing this setting cuts graphic inheritance. To showcase this, we will open the inserted instance in a new 3D window. Currently, we are able to move the pillar in the 3D window, and we will see that it is also moved in our frame. Now we will lock the structure of the graphic and apply the changes. Now it is no longer possible to move the pillar in the 3D window. If we show the graphic of the first pillar again, we will be able to move it since we didn't lock the structure. To explain the Show Content checkbox, we will create a new black box frame. Unlike a glass box frame, a black box frame does not show its contents to the outside. However, the black box frame must have a representation to the outside. This representation is not possible because it is not shown to the outside. The other representation are the external graphics. First, we insert 4 stations and connect them. If we now switch back to our model frame and insert the black box frame, we will see that it is represented to the outside with a default graphic, and the content is not shown. We will change this now. First, we switch back to the 3D window. Then we switch to the View ribbon and select Show External Graphics. Now we can see the graphic which represents the black box frame to the outside. We delete this default graphic. Then we insert factory walls and assign them to the external graphic group. Then we will additionally insert a cuboid, which we also assign to the external graphic group, and transform it to the roof of our factory. If we now again switch back to our model frame, we will see that the black box frame is represented by the factory walls and the roof. We also notice that the stations are not shown. The stations are the content of the black box frame. If we now open the Edit 3D properties of the black box frame and switch to the graphics, we can check the Show Content box to make the content of the black box frame visible. Basically, what we have done now is to convert the black box frame into a glass box frame. Black box frames and glass box frames are not 2 different types of frames. They just differ in the settings for show content and external graphics. Now let's assume that we want to edit something in the black box frame. To do so, we open it again. However, as you can see, the factory walls and the roof are also shown. This is not optimal, because you generally want to edit the content of the black box frame, and to do so, you do not need the external graphics. The external graphics of the black box frame are just the representation of it to the outside. To solve this, we can switch again to the View ribbon and deselect Show External Graphics. Now only the internal graphics and the content are shown. However, if you decide to keep the external graphics visible, it might be very helpful to lock the structure of them. In this way, you won't accidentally move or select them. To show the difference between a black box frame and a glass box frame even more clearly, we create 2 of each and rename them accordingly to distinguish them better. Then we insert them into the frame and open the Edit 3D Properties dialogs and switch to the Graphics tab. The default graphic group in both of them are the external representations of them. As we can see in the black box frame, it is set to visible. In the glass box frame, it is not visible. This makes totally sense, because we want to represent the glass box frame to the outside by its content. Therefore, we do not need an external graphic that is visible. Hence, the Show Content box is checked for the glass box frame and unchecked for the black box frame. You might ask yourself now why there is a deco graphic that represents the glass box frame. Per default, there is a deco graphic which makes sure that the object can be seen, even if no object is inserted. Once you have inserted objects, you can delete this graphic. Additionally, you might ask in which use cases black box frames are used. Let's assume that you have a production facility that consists of several areas, but you do not want to visualize all areas in the model frame. You could now take a cuboid of length 1 by 1 as an external representation for the areas that you do not want to visualize. Thus, a sub-area would be represented by this cuboid, which could be of arbitrary size. This could be used as a possibility to increase the performance for large productions, since one does not have to present all sub-areas. To explain the checkbox exclude from show content of the location, we close the dialogues and open the class of the glass box frame. Then we align the model frame and the 3D window of the glass box frame next to each other. Now we replace the deco graphic with the station and insert a variable object. As you can see in the model frame, the station is shown. However, the variable object is not displayed. The reason for this is that the checkbox exclude from show content of the location of the variable object is checked. This basically means that it is prevented that the external representation of the object is shown together with the external representation of the location of the object. To avoid this, we will uncheck the checkbox. If we now switch to our frame, we will see the variable object. Now we again open the Edit 3D properties of the station and switch to the States tab. In the States tab, we can adjust the visualization of the states. By default, the states of the station are shown vertically on a pole. If we now click on Show All Possible States, we will see all the possible states on the pole. We can change the orientation to horizontal and apply the change. If we now again click on Show All Possible States, we will see that they are arranged horizontally. We can also adjust the position and could bring them in front of the station by setting the y-coordinate to -1 and the z-coordinate to 0. Additionally, we can mirror or scale the graphics of the states. Now we will hide them again and move to the Captions tab. In the Captions tab, we activate the name and the label. You will now see that the name is displayed. Here we could now again adjust the position. Additionally, we can open the dialog of the station and add a label to the station that will then also be shown. With this, we have explained the most of the tabs in the Edit 3D Properties dialog. Now we will have a look at alignments of objects in the model frame. To do so, we place 3 stations into the frame. Now we select them all and right-click on one. We then select Arrange Objects. We can now arrange the stations as needed. If we click, for instance, on Align Y-coordinates, the selected objects will be aligned to the Y-coordinate of the station we have right-clicked. The same applies for distributing the objects. Additionally, we can select Transformation Inheritance. Here we can select if we want to inherit the positions, the rotations, the mirrorings, or the scalings. We could also select to inherit all of them. Here, all fields are grayed out, as the classes of the objects are located in a folder, preventing to inherit the transformations. This concludes our video on an introduction to 3D graphics.